Thank you so much, Ara. Appreciate it. Thanks everyone for joining. Hope everyone is doing great. I'm going to talk about something that is very critical for us to not just to be able to succeed, but also to be able to improve our reputation as software developers. So I'm going to spend the next about 40 minutes or so talking about what we really need to focus on in order for us to succeed with agile development. Well, we all talk about agile development, but I always want to think about what does it really mean to be agile and what are some of the things we need to really do in order to focus on it. And I'm not going to be talking more about methodology, but I'm going to focus most on what we can do as developers and testers and engineers. What are the things we can contribute in what we do? But let's step back a little bit and talk about how the world is today in terms of developing software. You know, I started writing code a few decades ago. I've been writing code for about 35 years, and I love programming. But when I look at the programming landscape, it's just absolutely fascinating how much things have progressed in terms of what we do. And I can probably summarize that with one simple thing. And I want to lead into the fact that we need speed. We always are talking about, are you done yet? Are you done yet? And we live in this mentality of we want to release software very quickly. But I want to emphasize that speed without discipline is a recipe for disaster, and how we can prevent that, how we can eliminate that. Well, we are working in a world with a higher level of abstraction. That's what we are working on today. Is the way we used to write software is quite different from the way we write software today. And moving forward, we are talking about higher level of capabilities and abstractions. Well, that's common trend, not just in terms of programming, but in terms of life as well. So I want to look at a landscape of what we do as human beings. And essentially, it really comes down to the aspect of being able to look at the life in general, right? As programmers, we write code, but as humans, we do several different activities in what we do, in what we live. How do we accomplish and what are we doing? We're building on higher levels of abstraction constantly in what we do. But there is a major shift in what we do right now compared to only maybe 10 years ago or 15 years ago, if you will. So this is where the paradigm shift of the 90s comes in as an example. So if you look back at the 90s, one of the major things we did is we went from structured programming to object-oriented programming. I remember the days as a young programmer talking about and listening to people continuously argue if object-oriented programming was really useful and good and if we would be succeeding with it. It's kind of, interesting to watch that 30 years later and things have settled down. Everybody has gotten onto that bandwagon of object-oriented programming. You don't have to convince anybody today that we should be doing object-oriented programming. In fact, we probably are overdoing it, if at all, and we could be, looking at it. So that was a major transition back in time, going from a structured programming to object-oriented programming. And that was the trend of the past. But what about the latest paradigm shift? What are we focusing on today in the world of programming? And I'm going to say that trend or that shift is from imperative style of programming to declarative style of programming. In fact, I would go to the extent of saying imperative style of living to a declarative style of living. Let me expand on that a little bit. But you may ask the question, but wait a minute, you're saying declarative but not functional. But isn't functional programming really the new rage that people are talking about? And almost every language wants to really promote that functional style of programming. Isn't that what we are really after? Well, I'm going to say that's not the fundamental in here, because it turns out on one hand, we use the imperative style of programming where we tell what to do, but also spend the time saying how to do it. On the other hand, in declarative style of programming, we tell what to do and not how to do it. Well, we let the underlying libraries decide how to actually implement it. Well, as it turns out, functional style of programming is declarative style of programming. So not everything that's declarative is functional, but everything that's functional is declarative. As it turns out, functional style is declarative plus the use of higher order functions. And that's the reason why I focus on declarative a lot more than being functional, because it encompasses the functional style into it as well. But let's dive in and look at this a little bit more, if you will. In the imperative style of programming, we tell what to do and also tell how to do it. The details are on your face. Whether you like it or not, you have to endure the pain of all the details that are given to you all the time. And let's take a look at an example of that really quickly. And in declarative programming, we focus on what to do and not as much on how. So let's think about declarative in code for a minute. Now, here is a little example of a collection of names. I've used JavaScript in this particular example, but you could do this in multiple different languages. So here is a list of names, and I want to find how many names are 4 letters in length. So you typically create a variable and then you loop through the values in the collection, check if the length is what you expect, and if it is, you increment a count, and then of course when you're done with it, you can say how many words were of that particular length. Well, that's an imperative style of programming because we tell every step of the way, every single detail. Create a variable called count, start looping. You need to increment a particular loop index. You got to get the value like that. Here's how you compare. Notice that you have to say every single detail. How does it feel to program in an imperative style? Well, it's like, you all probably know this already. In a family gathering, you want to avoid that old uncle because the minute you say hello, 3 hours of your life is wasted. So the minute you see, you take the next exit because that's too much of a detail you bother to know about. So the details are on your face, whether you like it or not. On the other hand, you can take all that noisy code, throw it away, and you can rewrite it in just a small, concise piece of code. So you can say names.filter, and you are extracting only the values you care about, where the length is a 4, and then you simply ask for the length or the number of elements in that collection. So this really eliminates the verbosity in the code, and the code begins to read like the problem statement. Now, as it turns out, this declarative to imperative is not just in coding the law as well, if you will. In the terms of a declarative style of programming on the front end, if you will. For example, well, how did we write front-end code a while ago? Well, you could write code like this. Let element is equal to get element document by element, get element by by ID or whatever that you would ask for, and then you would perform the logic of the computation and you would set different logic. So if you really think about it, I want to ask the question, what is front-end programming? And I'm going to say front-end programming is really a combination of 2 things. One is making AJAX calls plus, if you will, a DOM manipulation. So essentially, you are basically doing DOM manipulation. But what does it mean to manipulate the DOM? Well, you have to walk through the DOM elements on the browser, and you have to walk the hierarchy. And once you find out what you're working with, you issue commands to manipulate it. Well, if you have never done DOM manipulation, the first day you do it, it might be exciting. About the 3rd day you write code to manipulate the DOM, you realize that job should be given to people in the prison, and nobody in the free world should be forced to manipulate the DOM, isn't it? Because that is so boring, verbose, error-prone, tedious, and it's not, it takes the joy out of writing code because it's too low level and boring. So DOM manipulation is really not a fun activity. In fact, you could argue that imperative style, in a sense, imperative style is really, in the case of DOM manipulation, you can say that's basically what you are dealing with when it comes to programming. Now, on the other hand, if you really think about it, I'll draw an analogy. And then don't get me wrong, I respect everybody for what they do, but for me, I really don't care a whole lot about cars. That's just me. Cars are things I use to go from one place to another. There are people that I know personally, good friends, good family members, and they would be endlessly talking about cars. I don't care about cars as much. I would go to rent a car, and I'm not even kidding with you, I'm not exaggerating. The rental car company will ask me, what kind of car would you like to drive? And I would always tell them, could you please give me ones with the wheels, please? And they look at me and say, really? You don't care about the car you drive? And I would say, seriously, I don't care about the car I drive, just I need something to get me from one place to another. So I would say DOM manipulation is like driving a stick shift. Now, again, don't get me wrong, there are people who love cars and they would endlessly want to be messing around with stick shift as they drive. Not me. If you may catch me do many things in my life, but I will guarantee you, you will never catch me drive a stick shift. And I cannot understand why any human would want to sit in a car and keep putting these drives into shift as they drive along, just not me. So in terms of living, driving a stick shift is like, for example, DOM manipulation in programming or an imperative style of living. On the other hand, if you think about this a little bit further, you could say, hey, wait a minute. You could use something like jQuery to get your work done. So you could say something along $1 and then a pound greet, and then you can manipulate it and you can say, set the value. Hey, thank goodness we're not getting the values. We're not doing inner HTML. But what are we really doing? Well, if you're using something like jQuery, are we really doing something superb and better? And I'm going to say if you're using something like a jQuery, don't get me wrong, is a great library, but still, that's like taking morphine or very heavy dose of a painkiller because it eases the pain, but it doesn't remove the problem from your shoulders. So I would argue this is still imperative style when it comes to using jQuery. And now you may wonder, what does that really mean in terms of driving a car? I'm going to say this is auto transmission, and basically you can put the car into drive and you can put the car into cruise maybe and just hold on to the steering and you can be driving around. So you're still driving, you're still navigating, but at the same time, at least you don't have to be dealing with the stick shift over and over. You put that in drive and you can focus on it. Well, at least for the most part. Unfortunately, as I know, I live in Colorado where we have a lot of mountains, and oftentimes I've got to put it in low gear when we go down the gradients, so I still have to be driving. And as I said, I'm not a big fan of cars or driving for that matter. But what can we do? How do we get to a declarative style of programming? And eventually, of course, asking the question, a declarative style of living, if you will. Well, here is where some of the tools or the libraries really come in. Well, in this particular example, I simply said a selector for a greet, and then I said a template I want to provide where the name is what I want to modify with a particular value. Well, you may recognize that looks a lot like Angular code, but you can do this in multiple different languages if you will. You could use, for example, you could use Angular if you want to. You could also use, for example, React or Vue and so on and so forth. But what is all this really leading up to? Well, what this is really leading up to is a declarative style of programming on the front end. So if you really think about this in terms of the imperative versus declarative style, where is it really taking us in general? So I'm going to say trying to drive a stick shift car is like imperative style of programming, manipulating the DOM and feeling really, really troubled by the amount of effort we have to put, the verbosity and the error proneness of it. Well, you could argue that you could put it in auto shift and keep driving. That's like using jQuery. But I am more these days of a Lyft or a Uber kind of a person. I simply flag down a particular automobile, I get in, and they take me where I want to go. The other day I got into from the airport, and I got into the back of Uber, and I sat down, and the driver said, "Where would you like to go?" And I said, "I would like to go to this particular address. Here's the hotel." And the driver said, "Which route do you want to take?" And I said, "Honestly, I really don't care. And all I care about is you get me there safely. I want to tell you where I want to go. I'm not going to tell you how to get there." Well, that's really declarative style of living. And we see this more and more and more today, where we automate things around us, delegate things around us, if you will. So you could use Uber or Lyft, for example. And I'm not even going through the extent of a self-driving car, because in the case of a self-driving car, I'm still involved in driving to some extent. But what if we look at this a little differently? So the nature or the trend, if you will, is automation and delegation. So this is something that I'm thinking more and more, and I'm just looking at my own life around me. You know, the way I lived 30 years ago, the way I programmed 30 years ago is quite different from the way I live today and the way I program today. And in general, what I notice is a higher level of abstraction on one hand, but at the same time, more automation, more delegation, so I can focus on more pleasurable activities and intellectual activities than do mundane things that a machine can do or somebody else can do it for us. So delegation becomes very critical and automation becomes very critical. This is how we are living our lives today compared to years ago. You know, I'm living right now in what they call as a smart home, and I jokingly say I feel like the home is smarter than me sometimes. But the beauty of this is a lot of stuff is automated around me. So I don't have to be pinging myself over and over asking, did I shut the door? Did I put the lock? Did I secure the environment? Rather, I can focus on what I want to do and let the systems around me, the environment, take care of it. Automation and delegation. So essentially, that is basically one of the things to focus on. How can we bring that experience to us as programmers as we go along? What is the impact of such high level of abstraction and delegation automation on us? Well, we'll talk about that. In terms of it makes life expressive, it makes things concise in code, it really becomes easier to maintain, less error prone as well. And we can also engage with rapid change. And that's one of the real advantages is faster time to market, faster time to update. That's what we are really focused on. But then, of course, it really comes down to economics. And I always ask this question. When you walk into a building to write code or to develop software or to deliver value to your clients, I always ask people, what is the economic impact you have on your business today? What are you contributing? So it's the economic impact that is absolutely important. But let's talk a minute about JavaScript. You know, I program in about 15 different languages. I love programming languages, but I wouldn't say I'm good in any one of them. That's one of the reasons I get excited about languages, because I constantly learn. But JavaScript is special. I've been programming in JavaScript for decades, and I have a love-hate relationship with the language, just like a lot of others do as well. I would say JavaScript is a great example of this notion of a black swan in our industry. And this is something we never anticipated. You know, if somebody comes to you and asks you, after all these years, what's the most popular and powerful language? And what if you say one of them is JavaScript? What a disbelief, right? Nobody expected this language to survive this long, leave alone to be so successful. But on the other hand, a lot of us use JavaScript every single day. But how do you feel about writing code in JavaScript? Let me summarize my feelings about it. It is like a very powerful chainsaw. Don't get me wrong, it's one of the most powerful languages, but it's something you don't want to swing along. It's really, really dangerous. You got to be careful how you use this language. Well, if I want to summarize my feeling about the language, here's my summary about it. I want to say that JavaScript is like an infant. It's cute to play with, but you have no clue why when it begins to cry. And it's very frustrating when you program with languages that are as powerful, but at the same time, it's a slippery slope when it comes to writing code with JavaScript, because when things don't work or works differently and misbehaves, it becomes agonizing to understand and to be able to fix it. So what can we do to improve our journey and accelerate our development process? Well, we all talk about agile development. So agile development is gaining a lot of popularity. Unfortunately, though, a lot of people who talk about agile are talking about doing agile rather than being agile. And I'm going to say, don't do agile, instead be agile. But how can we really achieve agility? But what is agile development? I'm going to say agile development really is a feedback-driven development. That's what you really are after when it comes to agile development. After all, why do we want to be agile? Well, the reason really is we want to be able to respond to change as quickly as possible, as reasonably as possible. Now, in order to achieve this, what are we trying to do? Even late in the development. So what does it really mean to be agile? Well, that is the spirit of agility. The spirit of agility is to be able to change even late in the game. Unfortunately, though, in a lot of projects, what happens? Well, let's think about our lives as programmers every day. You are asked to make a certain change, fix some bugs, add some features, make some enhancements, and you finish that. And then people ask us this dreadful question. They ask us, does it work? And what's the answer we often give to people when they say, does it work? We often say, I hope, don't we? That's a sentiment we all carry as developers. We say, I hope. Well, there's a name for that kind of sentiment. It is called JDD, which stands for Jesus-driven development. We put faith in the Lord and say, dear Lord, please let my code work. Well, unfortunately, Jesus-driven development is not a great strategy. Don't get me wrong, I put faith in the Lord as well, but for more important things than the code I write actually works. We need to be better. We need to do a lot better. So when it comes to agile development, I ask for the word sustainable development. So to me, development is not a sprint, it's a marathon. We are constantly working on improving a product, making releases, and so we need to really ask the question, how can we sustain this pace of development? This happened once when I was looking at a particular software, and I noticed how poorly it behaved on my machine, and I tweeted this. Don't bother testing software if it does not work. Your users will tweet about it. But think of the reputation as a company, as a team, as an individual. What do we want to do? And I get really upset sometimes when I look at our own profession. And once I tweeted the following, and I said, who is a programmer? Unfortunately, a programmer or a software developer development is a profession where people get paid to write poor quality code and get paid more later to clean the mess we create. We got to do better. We cannot claim to be a profession and not have the ethics and the reputation to deliver software that actually works, that is maintainable and we are able to respond to change to the customers, to the users. So how can we improve on that? Well, I mentioned that automation and delegation are highly important. So if automation and delegation are highly important, how can we achieve that? Well, you talk about testing often, but let me emphasize it. I love manual testing. And you say, oh my gosh, are you serious? You said all these, and now you say, I love manual testing. I do, but I want to emphasize what the word testing really means in this context. So I want to ask the question, what is testing? Testing gives us the insight into an application and its usage. So that is basically what testing to me really is. Testing gives us the insight into an application and its usage. Should I eliminate a few workflow? Should I alter the user interface? Should I think about maybe better performance? Should I think of better features to use than these features? To me, a lot of those fall into testing. So testing is really an act of gaining insight into an application. But for most of what we do is not testing, it's verification. So what is verification? Verification really is a question we want to ask. It worked, yesterday. Does it still work? That is verification. So most of what we do is not software testing. Most of what we do is software verification. So I want to emphasize verification is very, very important for us to be able to deliver results faster, to be agile. No human should ever be asked to manually verify if a piece of code works. Consider that an insult on humanity to go to a human and say, can you please check if the code that worked yesterday is still working? We should feel insulted as human beings to be asked to do what a machine can do for us. So test manually, but verify automatically. Testers and developers should focus on writing code and testing the behavior of the application for what it should do and how it can be improved, but not to verify if what worked yesterday still works today. So we need to automate the verification process. Well, but unfortunately though, I've seen three groups of companies in the world. There are three phases, I would say, of verification. One, where there is no automation. A lot of companies are still doing manual verification. I personally have interacted with companies where they still do majority of their verification manually, and there's such a real effort to reject automation because there are people who have been doing manual verification for years and they cling on to it. I think those companies will face a really bad debt over time. The second group is yes to automation, but these companies go hire people with really fancy titles, automation engineer or whatever that you could talk about. But here's the problem. Their programmers are busy writing code and fixing bugs, and Bob, the automation engineer, joins the company and comes around and says, hey, programmers, and they are like, hey, Bob, welcome to the company, but don't bother us, we are busy right now. Well, then, of course, Bob, the automation engineer, is sitting around and thinking, what do I do? And the boss, in the meantime, she says, Bob, I want you in my office on Thursday to tell me what you have done on automation. And Bob is like, oh my gosh, the boss wants a report. The programmers are not helping. What do I do? And Bob realizes, here's an idea. Let me automate the heck out of this at the UI level. Well, unfortunately, though, there's a name for it. Mostly UI level verification is the pathway to hell automation. This is not a great idea, and a number of companies have done this and have miserably failed at it. I personally have worked with a few companies where I've tried to get them off this particular idea because it's not really working well. And there's a beautiful name for this. They call this the ice cream cone pattern. The ice cream cone pattern is where most of the testing is done at the high level, either manual testing and or UI level testing, and very few things at a lower level. This is not very stable, and that's a disaster. It's an anti-pattern. On the other hand, a third maturity in this process is yes to automation at the right level to the right measure. So this is basically where the test pyramid comes in. We are not saying don't do any testing at the UI level. That's not what we are saying. Do write the test at the UI level, but you want to write more automation tests at lower levels and fewer as you go up. And you want to definitely automate every level of these tests as much as you can. But why is this so hard to really do? When I work with programmers, brilliant programmers, I would tell them go implement this logic, and they would come back and say it's done. But then when I go to the same programmers and say write tests before you write code, they would look at me and like, are you out of your mind? How could we write code before we write the test? And I used to wonder, why is it that programmers who are really good at writing code have such a difficulty writing tests before writing code? Well, the reason really is programming is, what is really programming? I'm going to say that programming is a series of mini exercises where we discover and move from, if you will, move from a set of unknowns knowns to a set of knowns. So this is basically the reason why we find it really hard, if you will, to be able to write tests without writing code is because we don't just write code. We keep discovering things along the way. And as a result, it becomes harder for us to write the test in the first place. But when you hear people say, this code is hard to test, what are they really saying? What they're really saying is that the design of this code actually sucks. So from the design point of view, testability is crucial. It's really hard to come back and test a bad code, so we have to really design for testability. So we want to really take these, test and write them, but it's really hard to test a large set of unknowns. So one way to tackle that is to take small steps, divide and conquer, but spike to learn from the experience. So spiking to learn from the experience is a very important approach where you do prototyping. And when you're done with it, throw the prototype away and come back and write test and write code. But is it really possible to do so? And the answer is yes. As an example, you could take a system, a full stack system, and write tests at different levels, and the pyramid of the test you can do. And I talked about this in the test driving JavaScript applications, and to illustrate how we can actually achieve such a criteria. But it takes discipline, it takes time, it takes effort. It's a skill we have to take to develop. But as an industry, I want to say, we want to build into that culture. And I'm going to say automated verification is the software equivalent of exercising. You may be in a group of people. You can ask people to raise the hand who thinks exercising is a good idea, and almost everybody will raise the hand. But if you ask the question, who every day actively exercises, a few hands will stay up and others go down. Why? Because we all believe that's the right thing to do, but do we have the discipline? We always come up with excuses. Oh, I have this and I have that and I have this to do, but are we ready to commit to it? I'm going to say in the software development field, we are in the year 1820. If somebody says, what year is this? Don't say 2020, say 1820. Why? Well, in the medical field, in 1820, people were dying at a very high rate after surgery. The death rate, if somebody went to surgery, they would be dead within weeks. And why? Because the rate of infection was so high in 1820s. And people were trying to find out, why is the death rate so high? If somebody were to go to the hospital to deliver a baby, you would tell them, no, do it at home. You'll probably have a higher chance of surviving. Well, as people were trying to figure this out, a gentleman named Semmelweis decided to experiment a little bit more and found that the germs were killing people. But of course, it was way early to prove this, and he didn't succeed, unfortunately. And years later, you had people like Joseph Lister and Louis Pasteur who came along and said, hey, we found out what's killing these people. It's the doctors walking around with blood on their coat, carrying the germs from one patient to another and killing these patients after surgery. And they introduced approaches to sterilize and all the tools and the environment used in surgery, and the rate of success went high. The death rate or the mortality went down after surgeries. Well, it took an industry-wide discipline in the field of medicine for us to improve. And today, if you walk into a hospital and if the doctor doesn't wear gloves, doesn't use proper tools that are sterilized and wants to, operate on you or even examine you, you're going to call out and protest and maybe report to the medical board because we expect a better standard, because our health relies on others having the discipline, others having the right mentality and doing the right things. That comes back to our field in software development. We are practicing a beautiful craft. I love what we do. Programming to me is my passion. I write code and I see the program evolve, and the ability to abstract things and see them come to life and execute is profound. We are in this beautiful craft. Let's turn that into a wonderful profession, because that's where our reputation resides, our ability to deliver software resides, and I think we can do better if we commit to it. I hope that was useful. Thank you so much for the time, and stay safe, and I look forward to seeing you all at another time. Thank you again.